Okay, so we're going to solve trig equations in this lesson. So solving a trig equation is real similar to solving an algebraic equation, just as you're going to use a lot of the same methods. So the first thing you always want to try to do if you can, some of them you won't be able to, but if you can, you want to isolate the trig function, which means get the function by itself, kind of like you want to get x by itself when you're solving for x in a regular equation. Then the second thing that you want to try is write everything in terms of sine or cosine or tangent, okay? And so this will come at the very end of your problems, and I'll show you how to use this because we're going to be using the unit circle to solve, and so if they're in terms of sine, cosine, or tangent, it's usually a little easier to solve. Then third, you can factor things. You can factor out GCF or you can backwards FOIL. Fourth, write things using identities. So one of the reasons that we just did those identities was to make these trig equations a little easier. And then fifth, we'll use the unit circle to solve. So these are not necessarily steps that you'll follow every single time. These are kind of similar to just suggestions that I gave you, like for the verifying or the simplifying trig expressions. So before we start, this little thing helps me, and I'll show it to you, but you don't have to use it if it doesn't help you. This is, I'm just going to find the sign, like the SIGN, of each of the sine, cosine, and tangent for each of the quadrants. And so if I look at the unit circle, if I look at the sign is the y. In the first quadrant, the y is positive. So the sign is positive here. In the first quadrant, if we look at the cosine, that's all the x's, that's going to be positive. And so if we have a positive over a positive, when we do tangent, remember tangent's y over x, or sine over cosine, so a positive over a positive is going to be a positive, which means in the first quadrant, all three are positive. Now if we look in the second quadrant, the sine, or the y, is positive. If we look at the x-coordinate is negative. And so then if we put the y over the x, a positive over a negative, that's going to give us a negative. And so the only one that's positive in the second quadrant is sine. Third quadrant, let's go ahead and look at the sine and the cosine. So sine's y, the y is negative, so is the x, so both the sine and the cosine are negative in the third. And if we put a negative over a negative, that would be a positive. And then finally in the fourth quadrant, if we look at sine, the y is negative. If we look at cosine, the x is positive. And so sine is negative, x is positive. So negative over positive is a negative. And so then for the last two quadrants, the only one that's positive is tangent. And then the fourth quadrant, the only one that's positive is cosine. And a lot of people will remember this by remembering the acronym all students take calculus. I can't spell. Okay, so I'm going to use this when I solve. Hopefully you'll find it helpful. I'm going to copy this over. Maybe. Alright, so I want to solve the following equations, and I'm going to show you first how to solve equations for just an interval that is talking about the unit circle. So from angles that include 0 all the way up to 2 pi. And so I'm only going to find basically angles that will make this true that are on the unit circle for this first set of equations that we're going to solve. And so let's paste this over, and I'm going to group it and then make this real small. Alright, so I'm going to try to, on this one there's only one sign. So if I had 2x minus 1 equals 0, the way that I would solve that is by getting the x by itself, adding the 1 and dividing by 2. So this is really similar to this. So I'm going to go ahead and add the 1 and divide by 2. So I'll get sine equals 1/2. So I'm basically looking for where the y coordinate is 1/2. And this is going to happen in two places. This 1/2 is positive. So I know that I'm going to have an angle in quadrant 2 and an angle in quadrant 1. So quadrant 1 and 2, because that's where the sine is positive. The other two, sine is negative. So I need an angle that's the y is 1/2 in first and second quadrant. And so then I just go to my unit circle. And so where is the sine? Where's the y 1/2? That's going to be at pi over 6 and 5 pi over 6. And so theta is going to be pi over 6 and 5 pi over 6. And those would be my two answers. I'm going to copy that. Alright, number 2. This one is similar to, whenever you get confused about these, think about it as like this. X plus square root of 2 equals negative x. So this is just like a regular equation where my variable is x. Okay, so if I were to solve this, I would get these x's together because they are like terms. So I could add this x over. So I'm going to do the same thing right here and add this sign over. So when I add the sign over, these are going to cancel out and I get 2 sine plus the square root of 2 equals 0. And so then now I can get this sign by itself by subtracting the square root of 2 and dividing by 2. So sine is going to equal negative square root of 2 over 2. So this is a negative number now. And so I'm looking for where the sign, or the y, is negative square root of 2 over 2. And so this is going to be negative in these two quadrants, the third and the fourth. And so I'm looking for an angle in the third and the fourth quadrants. And so when we go to our unit circle, the y is going to be negative square root of 2 over 2 at 5 pi over 4 and 7 pi over 4. So my answers here are theta equals 5 pi over 4 and 7 pi over 4. Alright, number 3. So I'm going to go ahead and get this tangent squared by itself. This is the same thing. Remember, we can just plug a variable in there. That's 3x squared minus 1 equals 0. And so if we were solving for this, I would add the 1 and divide by 3. So that's going to give me tangent squared equals 1/3. And so to get rid of this squared, remember, this squared right here is the same thing as the tangent, whole thing squared, equals 1/3. And so to get rid of that squared, I'm going to take the square root of both sides. And so this is going to give me the tangent equals, now I have to remember to put plus or minus whenever I take the square root. And I'm going to simplify this up here. This is the same thing as the square root of 1 over the square root of 3. And the square root of 1 is just 1. So I've got 1 over the square root of 3. The square root of 3 won't simplify into a pretty number. And so then I'm going to rationalize, and you should have rationalized this enough to where you know what this is. So that's just going to be square root of 3 over 3. So I'm looking for where the tangent is positive or negative square root of 3 over 3. And so since I'm looking for positive or negatives, I'm looking for an angle in all 4 quadrants. So positive or negative square root of 3 over 3, if I go to my unit circle, if I do the y, remember tangent's y over x, if I do 1/2 over square root of 3 here, square root of 3 over 2, and I take this and flip it and multiply, 2 over square root of 3, that's going to give me, the 2's are going to cancel and I'll have 1 over square root of 3, and if I rationalize, I'm going to get the same thing that I just got, which is what I wanted, square root of 3 over 3. And so this is going to be correct. I knew it wasn't going to be this angle because that's just going to be 1 when I simplify y over the x. And then this one is not going to give me a square root of 3 in the bottom, so I won't end up with square root of 3 over 3, which is what I need. So this is asking where is the tangent square root of 3 over 3? Well, that's going to happen at pi over 6, and so since it's plus or minus, I want all the pi over 6's. And so my answer for this one would be theta equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so then these are my 4 answers. So whenever you have a squared function and you take the square root, you're going to end up with 4 answers instead of 2 because you're looking for one in all 4 quadrants. Alright, let's do one like number 4. Now number 4 is one that's, you've got different trig functions in it. And so there's not a way that you could just get the cotangent by itself or the cosine squared by itself. So what you want to do whenever you have more than one trig function and you can't get it alone is put everything equal to 0. So I'm going to say cotangent cosine squared minus cotangent. I just subtracted this cotangent over to the other side and I'm going to set it equal to 0. And then I can factor out a GCF. So I'm going to factor out the cotangent, and that'll leave me with cosine squared minus 1. Now, if you had something like this, if you had x times x plus 1 in parentheses, and you had that equal to 0, the way that you would solve this is by setting each of these equal to 0. X and x plus 1 equal to 0. So you would set x equal to 0 and x plus 1 equals 0. You're going to do the same thing right here with these problems. And so I'm going to set cotangent equal to 0 and cosine squared minus 1 equal to 0. Now, cotangent is sometimes easier to work with than just changing it to tangent. Okay, so I'm going to change this to, or I'm just going to look at cotangent. I know cotangent is x over y. And so if I'm looking for where this equals 0, then I'm looking for where this fraction equals 0, where the x over the y is 0. And the only time a fraction is going to equal 0 is when the x coordinate is 0. So on my unit circle, where's the x going to be 0? That's going to happen at pi over 2 and 3 pi over 2. So from here, I get theta equals pi over 2 and 3 pi over 2. Now, from this one, I'm going to go ahead and add that 1 over. So cosine squared equals 1. When I take the square root of both sides, that's going to be cosine equals plus or minus. The square root of 1 is just 1. So I'm looking for where the x, cos is x, where is it going to be plus or minus 1? So where is x plus or minus 1? That's going to happen at 0, pi, and I'm going to go ahead and include 2 pi here. So 0, pi, and 2 pi. So theta equals 0, pi, and 2 pi. And so all 5 of these answers are solutions to this equation. And so you would write all 5 of them. Alright, this one is one that has a secant in it. We haven't really looked at ones that have secant and cosecant in them yet. So we're going to look at this one, and then this one's a little bit different than the ones we looked at before because this is something that is going to be similar to a quadratic problem. And so with a quadratic problem, we're going to backwards FOIL. And so we're going to do the same thing with this, but in order to backwards FOIL, I need to get everything set equal to 0. So I'm going to subtract or add this 2 secant over to the other side, and I'm going to go ahead and put it in the middle. And so then I've got this. Now, this is going to give me something that I can backwards FOIL. But before I do that, I'm going to make this a little easier by factoring out a 2. So this is going to be secant squared plus secant minus 2. And now I can backwards FOIL. So it's going to have to be secant and secant. It'll have to be 2 and 1. And then I'll have to have plus 2 minus 1. So then I'm going to set each of these factors equal to 0. If I set 2 equal to 0, though, it doesn't give me any solutions. 2 doesn't equal 0. So really I'm just setting secant plus 2 equal to 0 and secant minus 1 equal to 0. And so this is going to be secant equals negative 2 and secant equals 1. Now the easiest way to do these are to change these secants into 1 over cosine. So I'm going to change these into 1 over cosine, and you'll see why in just a second. And if I put these both over 1 and cross multiply, then I'm going to end up with negative 2 cosine equals 1, and then 1 equals cosine. Alright, I'm going to go ahead and solve this left one right here by dividing by negative 2. So then cosine equals 1 divided by negative 2 is just negative 1/2. And here cosine equals 1. Alright, so now I'm looking for where the x coordinate, and I'm going to copy and paste this over. So I'm looking for where cosine is negative. And cosine is going to be negative in the second and the third. So I'm looking for an angle in the second and the third where the x coordinate is negative 1/2. And so that's going to be 2 pi over 3 and 4 pi over 3. So right here theta equals 2 pi over 3 and 4 pi over 3. And then where does cos equal just positive 1? That's going to be on one of the axes. So where does cos x equal positive 1? That's going to be at 0 and 2 pi. And so I'm going to list them both. And the reason that I list them both is because in the beginning we said that we were solving for this interval, and so I want to include both of those values, 0 and 2 pi, if they are solutions to this equation, and they are in this one. So these are my 4 answers for this one. And I'll do the rest of these examples in the video part 2.